Okay, so now we're on to lesson 114, and lesson 114 is nonlinear inequalities. So this is similar to linear inequalities. So just as a refresher, we have cases where um, you have your y-axis and your x-axis, and if you have some line like this equal to, in mx plus b format, mx b, this is the line y equals mx plus b, and if we say that y is greater than or equal to mx plus b, we're talking about all the points above the line, and if we say y is less than or equal to mx plus b, oh, and by the way, this is greater than or equal to, so it includes the line. Y is less than or equal to mx plus b, we're talking about all the points from the line downward in the negative direction. So we have a similar case for nonlinear, typically all the different shapes that you have for like quadratic equations and circles, things like that. So for example, if you have a parabola, something like this, and let's say it's, let me just give an example here, y is equal to x squared minus x squared plus 4x minus 1. So this is our nonlinear equation, our quadratic equation. If we say that y is less than or equal to this equation, we're basically talking about it's less than or equal to, so it's including the parabola and everything below it. And if we say that y is greater than or equal to the same equation, we have everything above it. And above it is being a little bit loose with that term because this is really points next to it, but it's technically above it in the y positive direction. Okay, so then how do we solve when we have two equations? So let's go ahead and jump into the examples. And remember, when we're solving system of equations where we have more than one equation, and we are trying to determine what the solution set is for that, it's going to be the set of points that satisfies both equations. And when we say both equations, we mean typically an intersection of the two solutions for the two equations. So let's look at 114. I guess just the first example, 114.1. So we have something that looks like this. We have our parabola facing downward, and then some line here, and they're giving general areas. They have A, which is essentially everything above the parabola and above this line, and then we have B, which is everything in this enclosed space here. We have C, which is here and here, so basically everything below the line except for what's under the parabola. And then we have D, which is everything below the line and inside the parabola. So they want to know what is the solution if the two equations are y greater than or equal to minus 1 half x minus 1, and that's this line here. And then we also have, sorry, that seems a little bit unusual because, okay, I'll hold off on that dot here. And then we also have y is greater than or equal to minus x squared plus 4x. This is the equation that I just used in the example before. Minus 1. Okay. So this is our line, this is our parabola. So the solutions to y is greater than this line is basically everything from the line upwards. So it's A and B. So we'll just write this is A and B. Hopefully you can see that. Yeah. And then the solution to this one is greater than the parabola. So it's basically everything above, so it's A and C. So So if the solution to this one is A and B, the solution to this is A and C, then the intersection of those two is strictly A. So the solution to this is area A. Okay, what I was going to make a comment on, which seems unusual, is the slope of this line is in a positive direction, and yet we have a minus 1/2 x, and that seemed weird to me. That would mean that, it should slope this way, unless I'm missing something. Yeah, they